Hello, Advanced Algebra 2. These notes will be for Wednesday, 3/18. I have posted a blank page of graphs that you can use to work along with these notes, or you can just sketch your own graphs also. That would be okay. All right, and I will try to keep these videos short, under say 15 minutes, because I know some of you may be sharing computer resources and such with brothers and sisters. Okay, so that'll be kind of the plan of attack, is to keep these under 15 minutes. We're going to start for Wednesday, Thursday, and Friday of this week with a little review of what we have done. So we'll ease back into this, and I can get my feet underneath of me with making these videos and getting things posted and everything. Okay, so the first thing we're going to do today is we're going to review our exponential growth and decay graphs. So the first thing I want to remind everybody that an exponential has the variable in the exponent. And there are two kinds of graphs, growth or decay. It all depends upon what your b value is. In exponential growth, your b value will be greater than 1. And if you remember what happens, we get a graph that will run uphill some way, shape, or form. And if you remember, all we're going to worry about graphing are 2 points on this right hand side, depending upon what that b value is. But more importantly, also realize there is an asymptote sitting right there on the back half of this graph, on the growth graph, that our graph just continually gets closer and closer to as if we went out farther. Okay, exponential decay, that b value will be somewhere between 0 and 1, which means it's going to be a fraction or a decimal less than 1. And that will produce a downhill graph for us that will run somewhere in that area right there. Again, we will only graph 2 points on that right hand side. Probably more important for us is to realize that the asymptote will then be on the right hand side of the x-axis. So really pay attention today where our asymptotes are, so that we can use those to get the back, to get that one side of our graph drawn. So let's take a look. I've got 5 examples. We'll run through them here. At any time you can pause the video, rewind the video. You could stop the video, do the problem, then press play and check your work that way. But I'll just run through these, and I'll leave it up to you to handle the playback of the video how you want to. Okay. All right, y equals 5 to the power of x plus 2 minus 3. We would start ourselves off with saying, what if it was just simply y to the 5x? Okay, our b value here is bigger than 1, so this means this is growth. So have an idea of what's going to happen here in your head. It's got to be taken off and running uphill. All right. We'll only worry about plugging in x values of 0 and 1. We know that anything to the power of 0 is a 1, and anything to itself is a 5. So that makes generating that table pretty easy. Okay. Now what happens to us here? We have an x plus 2 in our exponent. Remember, if it's in the exponent right there by the x, it even tells you x plus 2. That affects your x's, and it affects them the opposite of what it looks like. So it looks like we'll be adding 2, but we will take our x's here, 0 and 1, and we won't add 2 to them. We will subtract 2 from them, and we'll get negative 2 and negative 1. We have a minus 3 out back, which is not up in the exponent. Remember, that affects your y's, and that affects it exactly the way it looks, the same. So we will subtract 3 from our y. So we'll take our 1 and 5 that we have for our y values, subtract 3, and we get negative 2, and what do we get? Positive 2. Okay. Now also have in mind your head what's going to happen to the asymptote. Okay. What will happen to this asymptote here? Well, that x plus 2, which made us subtract 2 from our x's, will move it to the left 2 units. That minus 3 out back, which made us subtract 3 from our y's, will move it down 3 units. that will happen to our asymptote. So real quickly, our asymptote on a growth graph is on the back side, the negative side of the x-axis. That needs to be moved to the left 2, so you would start it back here, and it needs to be moved down 3. So when we draw our asymptote on our graph, it'll be down here. Okay, so let's look at what happens. We graph the points we have, 2, negative 2, negative 2. If I can get this to work, there we go. Negative 1, positive 2. Having a little trouble with my stylus here. There we go. Also, the asymptote, which would have been right there, I'm going to erase that, has been moved back 2 and down 3. So left 2, down 3 means my asymptote is right there. We want to know how to move that asymptote because then that allows us to sketch that left side of that graph. There we go. But again, that was a growth graph because our b value here was a 5, which is bigger than 1. So that runs uphill. All right, next problem. All right, problem number 2. Our b value is a 1/3, so that means this is decay. So know what happens with a decay graph. It runs, downhill. Also pay attention to where that asymptote is. It's on that positive x-axis. Okay, so we'll start ourselves off with just simply what would be the table for simply 1/3 raised to the power of x. Well, if we plug a 0 in, we always get a 1. If we plug a 1 in, we get whatever that b value is, 1/3. All right. But we have a plus 2. Whoops, getting ahead of myself. We have x minus 4 in our exponent, which means we do the opposite. We would add 4 to our x's, so we'll get a 4 and a 5 over here. The plus 2 that is outside means we add 2 to our y's. We get 3 and we get 2 and 1/3. Okay, so the points we need to graph are going to be 4, 3, and 5, 2, and 1/3. But also realize what's going to happen to this asymptote. That x minus 4 means it's going to move to the right 4. Okay, the plus 2 means it's going to move up 2. So let's do the asymptote first. So my asymptote, which normally would sit right here on that x-axis, not going to be there. It will have moved to the right 4, 1, 2, 3, 4, and up 2. It'll start right here and run to the right. Now our points that we get, this should make sense here. Let's see. 4, 3. 1, 2, 3, 4. 1, 2, 3. 4, 3. And what was our other one? 5, 2, and 1/3. So 5. Notice that 2 is where my asymptote is. I go a little bit further, and I'm at 1/3. That makes sense because my graph has to be running downhill along that asymptote. That is an exponential decay. So now that I was about ready to say, you've seen one of each. You can try the next 3 on your own. But let's do this one together because it has that times 3 out front. Okay. All right. B is a 4. That's growth. It's running uphill. In my head, I have an idea where my asymptote is. My beginning points would be 0, 1, 1, 4. In my exponent by that x, it says plus 3. That means I subtract 3 from my x's. Get negative 3 and negative 2. There are 2 things here we got to do to our y. Times by 3 and subtract by 2. Remember, you do the times by 3 first and that minus 2 last. So we'll times our y's by 3, get 3 and 12. Then we'll turn right around and we will subtract 2 from those and get 1 and 10. So the points we graph are negative 3, 1 and negative 2, 10. I also, in my head, will have an idea here. Let's talk about the asymptote. The asymptote will be moved left 3 because that says x plus 3, and it will move down 2 because it says minus 2 in the back. That's what will happen to my asymptote. So let's see if this all fits together now. Negative 3, 1. Negative 2, 10. My asymptote has been moved left 3, 1, 2, 3, and down 2. It will be down here. So it's important for us to get that asymptote correct, because remember one other thing, what that times 3 out front does. Remember in your graph, this first point we always graph as 0, 1, and then in this case, on this problem, the second point we would have graphed would have been 1, 4, if nothing else happens. So I'm talking about the graph of y equals 4x. What does that times 3 out front do? It makes everything be stretched 3 times further off that x-axis. So like this one here has a height of 1. This has a height of 4. So notice out here, this has a height of 3. This actually has a height of 12. That's what that times 3 does. Okay. Number 4. I see a times 3 out front again, but it's negative this time. So we'll see what happens there. Alright, so we're going to start off y equals 2 to the x. What would my table be for that if it's as basic as it can be? 0, 1, and 1, 2. Alright, what happens? I got an x minus 5. What's that make me do? Add 5 to my x's, 5 and 6. I got a negative 3 out front, so we're going to multiply by negative 3. And get negative 3 and negative 6. So our final points here are going to be 5, negative 3, and 6, negative 6. But let's talk about that negative 3 that we're multiplying by. So what happens, we would have had the original points of 0, 1, and 1, 2. Okay, that's what it would originally look like. What does 3 do out front to that? Well, it makes all these go up 3 times further. So instead of 0, 1, it'd be at 0, 3. Instead of 1, 3, it would have been at 1, or excuse me, that should have been 1, 2. Instead of 1, 2, now this will go up to 1, 6. Okay. If that's a negative 3, what does that do? That turns all of your positive y values into negative y values. So instead of this point going up here to positive 6, it would go down this way to negative 6. And instead of this one going up to positive 3, it would have went down to negative 3, and it just takes that red graph right there and flips it over the x-axis just like that. So that's why we need to know where this asymptote is, so we can use that asymptote to help us. Okay, so let's go back to ours. Let's talk about the asymptote. What has happened to the asymptote? The times by negative 3 does not affect our asymptote, but the x minus 5 does. That means our asymptote will move to the right 5. It's a growth function, so remember where your asymptote is. Your asymptote is sitting right here, starting at the origin and going back. We're just going to move that to the right 5. So let's do that first. 1, 2, 3, 4, 5. Okay. That's right there. What points did we generate? 5, negative 3, 1, 2, 3, and positive 6, negative 6. Right, 1, 2, 3 more, be right there. Then we know we can use our asymptote, get our graph drawn. Missed my dot, but that's okay. And it would be running down towards negative y's. But we got to get our asymptote drawn so we can get this back half of the graph drawn correctly. All right, number 5 is a decay, 1/5. So what would the table for 1/5 to the x be? I can tell you that 0 is a 1. 1 is whatever our b value is, 1/5. What do we have going on here? Well, we have nothing happening to our x's, so we won't change our x's. Our y's need to be multiplied by a negative 1, turning into negative 1 and negative 1/5. And remember what that happens? That is simply going to flip our graph over the x-axis. We also need to add 3 to our y's. So we will get positive 2 and 2 4/5. Okay. It is a decay function, so remember what a decay function does. It runs downhill, and our asymptote is over here. So the fact that we have that negative out front should flip this over that x-axis. So let's see. And also our asymptote needs to be moved up 3 because of that plus 3 in the back. So let's do the asymptote first. it would be now right here. Let's see if the points agree with that. What did we have? We had 0, 2. And 1, 2, and 4/5. Notice how my asymptote is at 3. 2 and 4/5 is below it. That's because that negative has flipped this over. You know, it used to be up here, but it got flipped over. Okay? All right, so your assignment will be posted. It will be a worksheet, 5 questions. And tomorrow I will post my key that you can check your work. So do your homework. You will need to turn your homework and your notes in whenever we get back.